we have the IOCCC Best Imaginary Emulator.
We had a rational one, an imaginary one. What do you imagine is these emulator?
I don't know.
Sure.
I imagine we'll find out after we see the trophy.
And the IOCCC Best Imaginary Emulator Award goes to Adrian Cable from the United States.
And I'll say, as a judge, you have to imagine that we have to come up with these award names. So give us a little bit of time, because our imagination sometimes runs away with us. But,
yeah. Is that it? Is that all?
That is the program. This is a program. It is, now obviously you see it's SDL. You see that it's got some fairly small piece of code. And what does it do? Well, I think we have a claim formatter version of it. And so you see that you've got up here some values, and you've got this for loop in here. And the for loop is doing some SDL stuff, and there's some little bit of these kind of arithmetic expressions. That's it.
Sure.
SDL wrapped around. Yeah, very large array of this thing. That's important. So let's see this thing in action, because this is amazing. This is there. So if we take the program and we read from standard input mandelbrot.boot image, what happens is it will print from outside the middle this nice Mandelbrot that's computed. If we instead say, let's say we take the prog. I'm sorry?
No, what size is the Mandelbrot boot image?
I forget what it is. It's a fairly good sized thing. If I recall correctly, it was a fairly large thing. Pixel macro. I think it's like you want like 800 by 512. So if instead we have it read a different file, pong.boot image, and run it, you get a little hint when you're trying to as to what's going on. You find let's go back again. What you have is an actual IOCCC Pong game. So we see there's the characters there. It's doing some Pong stuff. You've got characters to move one or the other paddles. One player's taking pair keys on one side, other is taking a pair of keys on the other side, and it keeps score up here, and set between player 1 and player 2, and eventually you get a couple of things, and when you win, the game stops. But there's more. If you were to wget this thing called vmlinux.boot_image and uncompress it and give prog a VM Linux boot image, again, that small program, reading from standard input vmlinux.boot_image, what will happen is it will boot. Waiting for it to do. Did it not do that?
Let's see. It should.
Should it go backwards?
Yeah, go back.
Should it go backwards? Let me go backwards here, and let me do this view switch thing. That's a thing here, and go forward.
There we go.
There it is. What will happen is it will boot Eternal Linux. You got LS, you got a busy box there. You can run a program FB clock, and it'll give you a nice clock. Control C that thing. You can run the Mandelbrot program, pi program, and it'll print digits of pi until you Control C it. or something bad happens. You can run Mandelbrot, which gives you your Mandelbrot image. You can go into the Doom subdirectory and run Doom, and you get is Doom running under this Linux, and it is real Doom. You can go and select your episode. You can select your skill level, run it, go down there, and this is you're running. You see it real time, and you can do the shoot at things and have it go bang. There it is. Yeah, it's the full Doom thing. You can go up the stairs. This is light on the monster. I accepted for this demo to get your so otherwise you'll be chomping on monsters. As I say, it's the real full Doom running there, and you can go on through the door to the next level of stuff. There you go. So, and of course you can quit. So there it is. And of course you can then exit the thing as a result. So what's happening is this is implementing a virtual machine of a one instruction set computer. Now, what is this one instruction set? It's a single instruction computer that consists of 3 32-bit operands. That's the only thing a computer does. So you start off at program 0. You fetch the next instruction, which gives you your A, B, C. If there's a low bit, any operand is set, you remove it. If the low bit is set, and you replace it with the operand indexed into memory. So that's how you pull something into memory. And then you do the difference between B and A and put that back into B. And if MB is negative, you set the program counter to C and go back to step 2. That's it. It's one instruction that does just that. That one instruction you saw is actually encoded in that one small C program, wrapped with STL to give you your sort of graphics stuff, and you saw it as standalone programs at the point of actually having a Linux that's compiled in this one program to run, to do all the other stuff. There is a challenge, and one of the challenges for you to, given, and you'll see in the description of this entry, the machine, the virtual machine, write a C compiler. You might use Clang in its description to write your own C compiler for that single instruction. And then go and produce a variant of that C compiler that contains, for variant of that Linux that has a C compiler in it, so you can start compiling code, your own code, and running. But it is a tour de force. It is just extraordinary. That small program is an actual virtual machine of a real machine that can do real work. You saw it run, and that wasn't sped up. That was real-time stuff. And congratulations, Adrian, for your 6th IOC winning entry. It's truly marvelous.
It is
and that machine,
pretty impressive.
Yeah. And that machine emulated is a mainframe because it's a word-oriented architecture. It doesn't have any byte addressing.
Yes.